Hello, I'm Philip Stoten. I'm at Apex 2014 and I'm joined by Stefan Adolffson from JOT.
From JOT, yeah.
Do you refer to it as JOT over here or JOT or?
We hear both.
Okay, so whatever, as long as they call you, I guess.
That is correct. Yeah.
And so tell me about what's new with JOT here in the US. What new products are you bringing out and who's driving that demand?
Yeah. Well, so we have a lot of products that are focused on domestic manufacturing. We have our new odd form placement. Of course, you cannot sustain financially a lot of people placing components on a board.
Yeah.
So we have that. We have a new mechanical router coming out.
Okay.
But I think that our most interesting products is on the test side.
Oh, okay.
Yeah.
Okay. So just before we go on to the test stuff, let's just look at the odd form.
Okay.
Which markets are driving the odd form? We're seeing a lot of, different size components very close to each other. That makes all that placement quite challenging.
Yeah, you need the accuracy. So it could be vision guided.
Right.
But I think that mainly the markets we are looking at is cost of labor. Increasing all over the place.
Okay.
A lot of manufacturing is coming back to the United States or never leave.
Yeah.
So
the key benefit is basic labor saving, particularly in a high cost environment like here.
Yeah.
Okay.
And when you get into automation, it needs to be high reusability, so that a short-term project will pay off for itself in a few months.
Yeah, of course.
So you kind of split up the cost between capital investment and expenditures.
And fast ROI is what these people are all about these days. They want that return investment, not in years, but in months or even in projects. And is it the automotive sector, the medical sector, consumer electronics? Which sector is having the most challenges in the odd form component side of things?
I'd say that it's definitely in smart products,
right?
Phones, tablets, games, and things like that, where you have a lot of new,
you have a lot of new devices,
cameras, and more computing power. So you have a high demand for, number one, placing your components accurately, but also maybe you're not allowed to touch the components with your hands. So that's the other aspect of
demand.
Odd form.
So functional test. Why do you think there's more demand for?
No, I think that the products are getting smarter, and even though maybe the cost of what you're testing may be relatively low, but they're normally a part of a very expensive product, and you cannot afford any failures. And then, of course, the systems that we have now, we have one system called M10, which is a vertical system, so you can save floor space.
Okay.
We introduced that actually a year ago, and now we're really seeing that taking off. And the product development we've done lately is dual drawers. So it's a vertical system that it's fully scalable.
Okay.
You can start with one box.
Yeah.
It has a slide. The slide goes in and out with a panel or board to be tested. So you have both power and air in the back.
Oh, okay.
So you can do the finishing touches in your office, and as the production demand arises, you stack them on top of each other, and then we can add a handler to automatically exchange the tested board to one to be tested. And so that's a very exciting product.
Some exciting new products. And in terms of markets, the US market seems to be doing okay. Mexican market seems to be doing particularly well at the moment.
Yeah.
Is that what you're seeing in terms of demand?
Absolutely. I mean, the Mexican automotive market is exploding, and I don't know how many PCBs you have in a car these days, maybe 40, 50, performing different functions. You have power steering, you have self-parking cars, you have entertainment modules.
The number we're using at the moment is $2,700 worth of electronics.
Oh, really?
That's the average for a car.
Yeah.
And with the potential to go to 4,000 in just a couple of years. So there's a lot there. Yeah. And as you say, that parking control, some of the piloted vehicle stuff, some really exciting stuff in that.
No, it is. And of course, that needs to be tested. And when you have these modules, you may have a touch screen or buttons, and you have an expected output. We have another product to test finished product or finished module called G3, which is an RF and RF shielded and soundproofed box with a robot inside, vision. So you put your finished product or module in there, and the robot is manipulating the buttons, checking the screens, making sure that the pixels are there, colors are right. If it is a mobile phone, we're testing the microphone, the speaker, intensity of the flash, the charger. We go through the sequence on the phone to make sure that everything is working.
And the robots can do the whole touchscreen thing these days.
Yeah, we have capacitive fingers. So you have a uniform pressure, always the same. Manual testing, you tend to, if it doesn't work, you press a little bit harder and say, it's fine. When it really isn't. So.
And interestingly, they are talking about pressure-sensitive touchscreens now, aren't they? This whole idea of three-dimensional touchscreen activity, where you press different strengths and get things. So that's going to create some more opportunities, some more test demand for you, I hope.
We hope so. We know so.
We know so. Stefan, thanks for popping by. A pleasure to talk to you.
Thank you.